world rocket sites are so many. The world rotates in anti-clockwise direction, but the rotational axis is actually 23.5 degree to the geometrical axis, and this is used for the flights arising mainly from USA, India, Russia, China, anywhere, but the rockets will gain from anti-clockwise direction because the earth rotates in the anti-clockwise direction. So they can fly them 23.5 degree uh, meridian, or they can make an angle, or if they are originating in India, they can make more than 23 to catch up the real rotational axis, which is at 23.5 degree. But the objects from Russia can fall over the ground, from USA can fall in the sea, and from other countries they can fall. But India, they can fall along the Malaysia, Cambodia, and
Wrapped up and ready for transport. The large canister moved to a locked storage shed after being under police guard since being discovered on a beach in Greenhead on the weekend. Authorities are yet to formally identify the item and its origin, but space experts say it likely originated from an Indian rocket launch.
I think the evidence here is pretty conclusive, comparing the pictures side by side. It's very obvious it comes from a very particular rocket, and I'm sure that with further investigation they can probably pull off a serial number and find out exactly how old this object is.
So the nearest origin for rocket to Australia is India. So many rockets have been launched. Which one is this? Australia says it belongs to India, but ISRO is yet to confirm. Is it from other Indian rockets, or is it from Chandrayaan 1, 2 or 3 is the main question. So here is my analysis on the rocket part found in Australia beach. Number 1, is it from Chandrayaan 1, 2, 3 or 2 and 3 at least? Okay, India has produced so many rockets, you can see designs, but let us try to zoom to the PSLV and LVMK used in Chandrayaan 1 and Chandrayaan 2 and 3. So this is 2 and this is used in the 3. So when we see the diameter of the parts, none of them parts in the stage 2 or 3 or 1 match to that. So it doesn't belong to Chandrayaan 1, 2 and 3. Now this one definite, because PSLV has got a stage 3 2 meter diameter, so the part definitely belongs to PSLV stage 3, what is found on the page. Now what is the stage separator mechanism used in this PSLV in the stage 3? Okay, let's see. At stage 2 the used is Merman band. You see, this is a different mechanism. You can beautifully enjoy how the craft gets released from the stage 2 gets separated from the stage 3. So the ring what you see is the Moorman ring. It has got lifting springs and it has got a explosive mechanism to release the latch, and the spring will release the upper stage. So upper stage goes into the sky and the lower one will fall. You can see another second camera and the first camera in the reverse way also. This is very difficult to shoot, but experimentally the space.com has done this job. But rest all the space agencies assume by mathematical calculations and algorithms it could be like this, it could be like this. But space.com has done a wonderful job. Now let's come to the stage 3 and 4 separation of the PSLV. So this is the ring, that is ball lock. So there is a ball and lock mechanism. You see how it falls, and here you can see in the slow motion actually. So there are two parts, upper part, lower part. In between there are steel balls, and the steel balls, when they jump to the another area, it gets released. This is actually the stage 3 of the PSLV. So this is the mechanism. So what do we see there? We see part of the rim and the dome, and we see the designs. All upper part is lower part of the clamp is there, the balls of the clamp are seen, and lower part is already burned, because it's a solid motor, it's going to burn, and only upper part remains safe because it is attached to the second stage, so it should not get burned. So here you can see the lower part, what is missing is that cone like structure, which is the nozzle is missing, and the brown part, which is really a insulating cover covering the internal part of this motor, is missing because it has fallen. So, and let us see the color wise, it matches to the copper I used. You see, is it belonging to spacecraft recent? No, because the barnacles take about 5 to 10 years. That is something between 2013 to 28. We got C20 to C40 launches, and the numbers are almost 24. So out of the 24, one of the PSLV has shed this particle, and this is floated and come to the thing. Now, is it possible to fall on Australia beach? Okay, here you see the flight pattern, around 512 seconds at 160 kilometer. The speed is 7.75 kilometers. And this is a location of Australia beach and the India, and the roughly calculation by the geometrical means is around 4006 kilometer. Can it travel 4006 kilometer? But see, during the stage of separation, it is already 512 seconds. That is coming to midway between the India and Australia. So from there, if direction is changed accidentally or pre-programmed, it can run towards the Australian beach, which is 2000 kilometer away. So at the speed of what is available there, it takes only 8 minutes 2 seconds to fall in near the beach of Australia, but it can float later on. What about the color? The color definitely matches to what we see during the assembly of the PSLV in the ISRO. You can see correct matching, the figures are shown there. So you believe yourself, this is the stage 3. You saw beautifully this in the wonderful video of ISRO. So the color definitely matches to PSLV stage 3 motor. Now the location, does it fit into the PSLV design of the ISRO? Well, you can see there the label 16, and the third stage motor is what is seen there. This is the upper part of the motor. So the part definitely matches to the PSLV design. And you see, these are all the points in favor for why I say this is PSLV. So PSLV is upper stage solid motor, and you can see various parts that I have identified and put there, including the
like
internal fabric. So these are all the 9 points from which I prove that this belongs to the PSLV.